Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Writhing Masses, or Writhing Mass, sorry, not masses, Writhing Mass, and it's by Tailsu. And here are the rules. We have normal Sudoku rules apply, which means fill the entire grid with the digits 1 through 9 such that there are no repeats in any row, column, or designated 9-cell regions. Digits along a thermometer must strictly increase from bulb to the tip. So, for example, you must be strictly increasing from the bulb to the tip here. So as an example, you could have something like 3, 4, and 7. That works. What does not work is something like 3, 3, and 7 because it's not strictly increasing from the bulb to the tip. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now I'm going to get started. Let's learn how to Sudoku. Okay. In this upper right-hand box, only bulbs in this type of thermometer can contain a 1. And the rest of the box is basically is on a thermometer and does not contain a bulb. So the 1 can only be here, right? Because these digits always have a digit that's greater than, these digits always have a digit that's greater than, these digits always have a digit that's greater than. So this has to be the 1 here. In column 8, similarly, where is the 1? 1 can't be here because they're all have digits greater than, it's greater than. Same here. So the 1 has to be one of these two digits here. Which means in this right central box, you can't have a 1 in any of these spaces or here because of the 1 having to be in one of these two cells. Therefore, in column 9, where is the 1? It has to be here. So we could do this similarly throughout. If we can find sets, we can also do this for 9 too. Where is the 9 in this upper right-hand box? It must be one of these two cells. Where is the 9 in column 7? Can't be here because it must be this must be less than that cell. Can't be here because it's less than those two cells. This is less than all 4 of these cells. This is less than that. This is less than both of these. This is less than these two. So the 9 in column 7 has to be one of these two cells. Well, in column 8 then, where can the 9 be? None of these cells are tips. These aren't tips. This isn't tip. These are tips, but because of the 9 having to be in one of these two cells here in column 7, there cannot be a 9 here. So neither of these could be 9, which leaves the 9 in column 8 to be here. So this is 9, which means this can't be 9. Well, where is the 9 in column 9 now? It has to be one of those 3 cells, but it's any of those 3. We don't know which. In column 6, where are the 9s possible? Again, 9s have to be on tips. So it cannot be any of these here. Can't be here because of the 9 in the row. Can't be any of these because they're not tips, so it can only be here. So this is a 9 here, which means this can't be 9 here. In column 4, where is the 1s? Cannot be here. Cannot be here. So 1 has to be one of these two. Where about the 9s? None of these are tips. This can't be a 9 because of the 9 in the box, and neither of these are tips, so this must be a 9 here. And 1s and 9s can also be on empty spots too, remember. But that's the reason why I'm looking at places where you have 9 digits, all 9 unique digits, all of which are on the thermometer in some sense. In row 2, where's the 1? there's no bulb except here, so this must be a 1, which means this can't be 1. So in column 4, where is the 1? It must be here. What about 9s? In row 2, none of them are tips except for this digit, so this must be a 9. Row 3. 9 cannot be in these 3 cells because of the 9 in the box. Can't be these 3 cells because of the 9 in the box. And neither of these are tips, so this must be a 9 here. What about column 3? Where's the 9? 9 cannot be any of these cells because of the 9 in the box. 9 could be here. Cannot be any of these. Can't be here. So 9 could be either here or here. We're not sure which. In column 3. What about the 1 in row 1? Can't be here because of the 1 in the box. Can't be here because of the 1 in the box. Can't be here because it's not a bulb, so it was one of those 2 cells. Where's the 1 in column 5? It has to be one of these 2 cells because it's a bulb. Can't be here because of the 1 in the box. Can't be here because of the 1 in the box. In... Okay. I was hoping this would give me a lot more information. Oh, this 1 eliminates 1 here. Okay, so that gives me a decent amount of information. So this is 1. Where's a 1 in row 4? Cannot be any of these cells because there's a 1 in those boxes. Can't be these cells because they're not bulbs, so this is a 1 here. Which means in this lower left box, where's the 1? We can't have a 1 here, we can't have a 1 here, and 1 has to be in a bulb, so this must be a 1. Which means this cannot be 1 here, this is a 1 here. That 1 here eliminates 1 here, so therefore in column 5, the 1 has to be here. 9 in this lower left box must be one of these 2 cells. In the left central box, it can only be here or here. Okay. What I like to do usually on thermometers, so I was trying to test this to see if this would go a better way. And you get a decent amount of 1s, and you get all the 1s, and you get a decent amount of 9s. But I still think this actually probably is slower than the way I typically do, which is I usually like to find long thermometers, or decently long thermometers, and go from the bulb to the tip, looking at what each digit can be at minimum. And then I look from the tip going back to the bulb, looking at what each digit can be maximally, and then we narrow things down. We restrict the cells that way. So, for example, this could be a 2. This could be, because we can't have a 1, because the 1's in the box, but the minimum value here is 2. This digit must be greater than that, so it's at minimum 3. This is greater than this one, which means this is a minimum 4, 5, 6, for similar reasons. Now, what's the maximum digits? This is 9, because that's the maximum digit in Sudoku. This digit is less than this, so it's the maximum digit of 8. This is less than that, so it's a maximum digit of 7, 6, and 5 for the similar reasoning. And we can fill in the digits in between the minimum and maximum for each cell. So this is 2, 3, 4, 5, 3, 4, 5, 6, 4, 5, 6, 7, 5, 6, 7, 8, 6, 7, 8, 9. And we could go about that for a lot of the thermometers. Now the question is, which ones are the more appropriate ones to look for, right? This is 2 at minimum, 3, 4, 5, 6. This is not 9 at maximum because of the 9 in this box. So this is 8 at maximum, 7 at maximum, 6, 5, 4. So we can fill in everything else in between. That's 2, 3, 4, 3, 4, 5, 4, 5, 6, 5, 6, 7, 6, 7, 8. This digit at minimum is a 2 because it's greater than 1. This digit must be greater than this, so it's at minimum 3. This digit is maximum of 4 because it's less than a 5. So this is 2, 3. This is 3, 4. This digit is maximum 8, maximum 7, minimum 2, minimum 3, minimum 4. This is minimum 6 because it can't be 5. And this is minimum 7 because it's greater than that digit. It's 6. So this is maximum 7, maximum 6. This could be maximum 5 because it's less than the 6. This is maximum 4. So this is 2, 3, 4, 3, 4, 5. So this is helpful, actually. This is minimum 2, 3, 4. So this is maximum 8, maximum 7, maximum 6. So this is 4, 5, 6, 7, 8, 3, 4, 5, 6, 2, 3, 4, 5. Well, in column 8, where is the 2 possible? Can't be any of these cells because of what we've discovered on the thermometer, what we've restricted. So this must be a 2. That means this can no longer be 2, so this can no longer be 3. This can no longer be 4 because this has to be greater than that digit. And if this was 4, it's not greater than 5 or 4. So this must be then a 6, which makes this 7. This is 8 then. That eliminates 7 here, so this is less than that digit, so it can't be 6. And neither of these can be 5 because of the 5 in the column. None of these can be 6 because of the 6 in the column. Well, where is the 3 possible in column 8? It can only be here. So this is 3, which forces this to be less than it, which is 2. Therefore, that leaves this as a 4, which means this can't be 4. This is 3. This can't be 4 because of the 4 in the column. So this can't be 5 because it must be greater than the 5 or 6 that's here. So this must be 7, which forces this to be 8. Therefore, this can't be 7 or 8. This is 4 or 5. This digit is less than that, so it cannot be 6. This digit's less than that, so it can't be 4. Let's continue. This digit is at least a 5 because we can't have 1 through 4 here. This is greater than 5, so this is 6. This is less than 9, though, so this is 8 at most. This is 7 at most. If this were 6, the problem is this would have to be 5, and that would eliminate all possibilities here. So this can't be 6. This is 7 at minimum. This is 5, 6, or 7 here, and that's fine. This is 2 at minimum, 3 at minimum, 4 at minimum, 5 at minimum. This could be up to 9, so it's 5, 6, and 9. This is up to 8 because this is smaller than that. This is up to 7, up to 6. So 2, 3, 4, 5, 6, 3 through 7, 4 through 8, and this is 5, 6, or 9. Well, where is the 8 possible in column 7? Can't be here because we have an 8 already in the box. Can't be here because this must be greater than it, and it must be less than 9, so this is 8. This has to then be, where is a 7 in column 7? Can't be any of these because of the 7 in the box, so this must be a 7 here. That makes this a 5, 6, 9 triplet, which eliminates 5, 6, and 9 in the rest of the box. So this can't be 5, 6, or 9. This is 4, which means this is less than that's 3, that's 2. This 4 means this can't be 4, so this is 5. This can't be 5, so this has to be greater than that. So this has to be at least 7, 8, or 9 to be greater than the 6, 7, 8. This 3 eliminates 3 here, so this can't be 4 because the 4, also the 4 is eliminated there. This 2 eliminates 2 as possibilities here. So this cell has to be greater than that cell, so it cannot be 3. Let's see, what else do we have? Where is the 8 in row 7? None of these can be because of the restriction of the thermometer. If we had an 8 here, there are 2 other digits higher than it, which is not possible. So this can't be 8. Therefore, 8 in row 7 must be here. And this must be 3, 4, 5, or 6. This is greater than that, so this is at least 4. This is greater than that cell, so this must be at least 5. It cannot be 9. Actually, the 9 could be here. I don't know why I did that. These 3 could be 9. So this could be 9. This could be 8. Actually, can't be 8. So this is at most 7. So this is 4, 5, 6, 7. This is 5, 6, 7, 9. Here's possibilities. Let's look at this lower central box. This digit can be 2. This digit cannot be 3, but it could be 4. It cannot be 8, so it's at most 7. Where this is at most 6 then. So this is 4, 5, 6, 7. This is 2, 3, no 4, 5, 6. This digit is less than 2 other digits, so it can never be 8. Where is the 8 in this box? It has to be here. So this is 8, which forces this to be 9. So this cannot be 9 here. This digit could be 2. This could be 4. This could be 5. So it's 5. It cannot be 8 or 9. So 7 is max. This is 6 at max. This is 5 at max. So it's 5, 6, 7. 4, 5, 6, 2, 3, 4, no 4 possible here. So 2 is one of these 2 digits here. Well, where is a 2 in row 8? Cannot be any of these cells because of what we've restricted by thermometers, so it has to be here. So this is 2. 9 has to be one of these 2 digits, which is fine. Two cannot be here. Where is the 2 in this left central box? None of these are restricted from being 2s by the thermometer. This can't be 2 because of this 2, and this can't be 2 because of this 2, so this must be a 2 here. Well, where does that leave the 2 in column 2? It can only be that cell because these 2s are eliminated by the 2s in the boxes. So this is 2. This is at minimum 3. This is at minimum 3 and minimum 3. That means 4 and cannot be 5. It could be 6 at minimum. This is at maximum. Cannot be 8 because of the 8 in the column. So this is 7. This is at maximum 6 then. This is maximum 5. So this is 4, 5, 6, 3, 4, 5. This is 6 and 7 specifically. 3 to 4 to 5 to 6. This is maximum 8. Maximum less than that, so it's 7. Maximum less than that, so it's 6. Maximum less than this digit, so this is 5. So this is 3, 4, 5. 4, 5. Cannot be 5 here. So this can't be 5. This is 4 or 6. This can't be 6, so it's 5 or 7. This can't be 7, so it's 6 or 8 here. This is less greater than this. This cell is greater than this cell, so this is at least 4. This is at least 6. So it's 6, 7, or 8. Cannot be 9. This is at maximum of 6 because it can't be 7. This is at maximum of 5. So this is 3, 4, 5. This is 4, 5, 6. This is 6, 7, 8 here. We have a 3, 4, 5 triplet in row 3, which eliminates 3, 4, and 5 in the rest of the row. This can't be 5, therefore this is 7, which forces this to be 6. This is greater than the 7, so this must be 8. This can't be 6. This can't be 5. The remaining digits in this upper left box must be 3, 4, and 5, but this can't be 4 or 5, so this must be a 3, which makes this 4, which makes that a 5. That eliminates 4, 5, and 6 in the rest of the column. This can't be 4, 5, or 6, so this is 7. This can't be 5, 6, or 7, so this must be 9. Which leaves this as a 3 here. So this can't be 3. This 7 means this has to be 8 and 9 to be greater than it. So this is 8, this is 9. This cannot be 9 here. 4 cannot be either of these cells. We have in this upper central box a 3, 5 pair, which eliminates 3 and 5 from the rest of the box. So this can't be 5. This is 4 or 6, which leaves this digit less than it, but it cannot be 3, 5, cannot be 4 or 6 because of the 4, 6 pair, can't be 1, so this has to be a 2 to be less than the 4 or 6. This 4, 6 pair eliminates 4 and 6 in the rest of the box, so this is a 7, 8, 7, 8 pair here. This 4, 6, 4, 6 pair eliminates 4 and 6 in the rest of the column, and the 2 eliminates 2 here, so this can't be 2. Where is the 2 in row 9? It has to be here. So this is 2. We have a 3, 5, 3, 5 pair and a 4, 6, 4, 6 pair in column 4. That eliminates 3, 4, 5, and 6 in the rest of the column. This can't be 4, 5, or 6, so this is 7. This then has to be an 8, because that's the only digit remaining. Let's see. This is at minimum. Okay, where is a 2 in column 6? All of these cannot be 2 because of the restrictions by the thermometers, so this must be a 2 here. This can be 3 because it must be greater than 2. This can be 4 because it must be greater than 3. This is not a 7 or 8. Cannot be 9 because it must be less than 8, so it has to be at least a 6. This is at least a 5. So we have 4, 5, 6, 3, 4, 5. We have a 3, 4, 5, 6 quadruplet in column 4, 5, which eliminates 3, 4, 5, 6 in the rest of the column. So this is 7 or 8. Cannot be 8 because of this 8 in the row. So this is 7, which makes this 8, which makes that 7. This cannot be a 9. So where's the 9 in column 9? It has to be here. This is a 4, 6 pair here in column 9. Where is the 3 in the central box? There's only one place it can be. It can only be here. So this is 3. That means this cannot be 3, so this can't be 4 because it must be greater than this cell. This 7 eliminates 7 here, so this is greater than that cell. This has to be less than that cell, so it can't be 6. We have a 3, 4, 5 triplet in this lower central box. That eliminates 3, 4, 5 in the rest of the box, so this must be a 6. Which means this can't be 6 or 7. This 4, 5 means this 4, 5, this can never be 5. If this were 5, it would be greater than this cell, or greater than or equal to that cell. So this has to be 3, which makes this 4, which makes that 5. This 4 eliminates 4 here, so that's 5. That's 5, makes this 6. This then has to be 3, cannot be 4, 5. This can't be 4, 5, so it's a 6, 7 pair. And this is 6, 7 pair because of what's remaining in the rows. This 6 eliminates 6 here, so it's a 5. This 7 eliminates 7 here, so it's 6. This must then be a 7. Remaining digits. This is greater than a 1. Cannot be 2 or 3, so it's at least a 4. This is greater than that, so this must be 5. Cannot be 7, 8, or 9, so it could be 6, and this could be 4, 5. One of these digits is a 5, because 5 cannot be here in row 5, so this can't be 5. One of these digits is a 6. This can't be 5 because of the 5 in the box. This 5 eliminates 5 here, so this is 3, which forces this to be 5. This 5 means this has to be a 6 to be greater than it. So this is 6, this is 4, this is 6, and this is 4. This 6 eliminates 6 here, so that's 4. 6, that 6 eliminates 6 here, so this is 5, 4. The 4 eliminates a 4 here, so this is 5, and this is 4, and that makes this a 6. Yeah, I was trying to look for a different way of trying to solve these thermometers because I do this way a lot, and I was trying to experiment looking for a different way. In the end, I still had to go through the way that I normally do. So, I mean, I don't know. It is a very good technique, so it's not, that it's a bad technique, so I was trying to avoid it. It's just that I was curious to see if I could solve it a different way, but I couldn't really. I mean, there could have been other ways to solve it, but it's just that this is an easy way to basically go about it, right? Without making mistakes also. So Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.